Hello everyone, welcome to my video. In this video, I will share with you how you can cut your DNA with precision, how will you set the reaction for restriction digestion. So all here you can see a plasmid DNA of 6000 base pair. I cut this plasmid into two fragments. One is nearly 1200 base pair and another is 1000 base pair, nearly 1000 base pair. So how I perform this restriction digestion, I will share with you on the basis of my lab experience. You can see the reaction setup here. On the basis of your requirements, you can set 10, 25 and 50 microliter of reaction. And what components do you need for that? The plasmid DNA or PCR product, the reaction buffer, the restriction enzyme, and sometimes bovine serum albumin, and of course nucleus-free water. And all you have to need it an incubator to incubate the mixture. Okay, so I will discuss about the reaction parameters today. Now let's talk about the reaction volume. Here you can see I have set up a 10 microliter restriction digestion reaction. Out of that I used 4 microliter of plasmid DNA. But how much plasmid DNA do you actually need? That depends on the concentration of your plasmid or DNA, which you should measure using a nanodrop or a similar tool. In my case, I extracted the plasmid DNA from bacteria, and after checking the concentration with nanodrop, I found it to be 34.1 nanogram per microliter. Typically, for a standard 10 microliter restriction digestion, you need around 200 nanogram of plasmid DNA. But I believe that 150 nanogram is sufficient. So I used 4 microliter, which gives me around 136 nanogram in total. Just remember, the more plasmid DNA you use, the better your results will be, especially if you are going to visualize the digestion on a gel. Next, I will discuss about the buffer. In this reaction, I used NAB R-Card Smart Buffer. The choice of buffer actually depends on the restriction enzyme you are using, since each enzyme works best in a specific buffer. I'll explain this part in more detail in very shortly. Now, how much restriction enzyme should we add? That depends on the enzyme and the guidelines provided by the manufacturer. For example, according to the NAB, 1 microliter of their restriction enzyme is sufficient to digest 1 microgram of DNA, which means 1000 nanogram of DNA can be cut by 1 microliter of the restriction enzyme. Since I only have 136 nanogram of DNA in my reaction, 0.5 microliter of enzyme is more than enough to cut my all the plasmid DNA. Once you have added the plasmid DNA, the buffer and the enzyme, just top up with nucleus-free water to make the final volume of 10 microliter. But here, sometimes you might need to add the BSA or bovine serum albumin to stabilize the enzyme activity. However, most modern buffer from NAB, including R-Card Smart, already contain the BSA. So I don't need to add it separately. In case if you are not sure whether your buffer includes BSA or whether your enzyme requires it or not, you can check the NAB's website or the enzyme datasheet. I will show you how to find this info in just a bit. Here you can see I incubate the reaction mixture for 25 minutes. It's not like universal. I used enzyme and buffer from NAB. According to NAB, their enzyme can digest DNA in 5 to 15 minutes. But some manufacturer like Promega requires some more incubation time. Let me show you. Okay, see the protocol from Promega. Their restriction digestion protocol. According to them, they say to incubate at the enzyme optimum temperature for 1 to 4 hours. So if you are using enzyme from Promega, you have to incubate your reaction mixture for 1 to 4 hours. If you are using the enzyme from NAB, they clearly said that their enzyme require 5 to 15 minutes for the digestion. You can see the protocol from here. I will put all the protocol in my description. Here you can see some restriction enzymes. They are recognition sites, whether they require heat inactivation or show star activity or not. I have used all of this enzyme in my lab. Among them, EcoR1, BAMH1, and XH1 produce sticky ends and are commonly used for ligation and subsequent cloning. On the other hand, SMA1 and EcoRV produce blunt ends. Whether an enzyme produces sticky ends or blunt ends depends on its cutting sites. So always check that carefully. If you are doing ligation or cloning, always choose the enzyme that produces sticky ends. Now, the most important part. If you want to perform precise restriction digestion, you must pay close attention to two things. One is heat inactivation and star activity. Most enzymes from NAB and other manufacturers require heat inactivation, except some like BMH1, here you can see, doesn't require any heat inactivation, and some high fidelity enzyme like EQR1. If EQR1 has its high fidelity version, it doesn't require heat inactivation. But that's all right, because heat inactivation is not so tough thing. You can easily heat inactivate any enzyme in thermocycler. Just set the thermocycler at 65 degrees Celsius for 20 minutes. However, few enzymes like EQRV requires a bit more, 80 degrees Celsius for 20 minutes. So, why is heat inactivation is so important? Because if you skip it, enzyme can keep cutting after your restriction digestion reaction has been completed, leading to over-digestion of DNA, which can damage your ligation sites, compromising downstream cloning steps, and which in case it may trigger star activity, causing the enzyme to cut at unintended sites. So if you have to take heat inactivation seriously, it can make or break your experiment. To understand star activity, I put a sequence here. Basically, when your enzyme has star activity, it can cleave DNA at sites similar but not identical to its recognition sequence. This can lead to unintended or non-specific cut in the DNA. I just give a short example for that. Here you can see GAA TTC, the restriction recognition sequence for EQR1. EQR1 are cut the sequence only if this enzyme find this sequence only. But when your enzyme has star activity, it can cut near a sequence like GAA, TTA, and GAA, TTG. They are not the recognition site for the EQR1. But if your enzyme has this star activity, this can cut this sequence also. Now I will show you from where you can find whether the restriction enzyme is required heat inactivation or not. You can simply find it on NAB website. As I am using the enzyme from NAB, if you're using the enzyme from Promega or Sigma, you can check their website too. Okay, so where you can find, just go down here and you can see heat inactivation 65 degrees Celsius for 20 minutes. Same as for Barnage 1, as I mentioned earlier, it doesn't require any heat inactivation. Just check it here, you can find it. Heat activation. What you can do, just go to the Google and search for EQRV. You can find many information here. Okay, so as my enzyme is from the NAB, just I will click into it and it will take me to their websites, the page. From here I can also see my enzyme has star activity or not. Okay, from the product notes. No, not here, just check here. Here you can see this enzyme may exhibit star activity. It's an EQR1 in NAB buffer or 2.1 or our customer buffer. Now, lastly, the buffer requirements. We have to check the buffer requirements, which buffer is required for each restriction enzymes to achieve 100% activity. There are 4 restriction buffer from NAB named this. You can also check which buffer you needed from similar websites. Here you can see that EQR1 show 100% activity in NAB buffer 2.1 and in our buffer it show 50% activity. If I go to the BNH1, you can see here in NAB buffer 1 it's showing 75% of activity, but in buffer 2.1, buffer 2, buffer 3 and our buffer it's showing 100% activity. So you can also check the buffer requirements from here. Here I mention some tips. Okay, during the reaction setup, always add the nucleus-free water first, then the buffer, then the DNA, and finally the enzyme. Actually, when you mixing up the restriction digestion reaction, it is like not easy like PCR or DNA extraction. Okay, I find it a bit of tough because it's, all enzymes and the buffer are sticky. I mean, when you are do the pipetting in the lab, you can easily observe that. But if you added the enzyme too early, it may start cutting the DNA prematurely before the reaction is properly set. So add the enzymes lastly. After assembling the reaction, mix gently and spin briefly to ensure everything is well mixed without damaging the enzyme. Lastly, if you are performing the restriction digestion well, you can find this type of bands. Here is the main bands of plasmid, and here is the restriction digestion fragments. Okay, so I can find here two fragments because in my plasmid there are two restriction site for XH1. That's why it cut into the two fragments. So thank you very much for watching this video. If you have any confusion, you can ask me in comments. Please, if you like this video, like it and subscribe for more the video.